I think that there must be a scientific explanation for spirituality. I don't think there's been a good one until recently. To me, the only one that makes sense is that proto-consciousness, platonic values, goodness, truth, exist at this fundamental level of space-time geometry, which can influence our actions if we're open to them, and interconnects us to all other beings, to the universe at large.
Science has told us a very bleak story. It's told us that we're some sort of genetic mistake, that we have genes that use us basically to move on to the next generation, and that we randomly mutate. It's said that we are outside of our universe, that we're alone, that we're separate, and that we're this sort of lonely mistake on a lonely planet in a lonely universe. And that informs our view of the world. It informs our view of ourselves. And we're now realizing that this view of separateness, is one of the most destructive things. It's the thing that creates all the problems in the world.
It's time to get wise.
And we're now realizing that that paradigm is wrong, that we aren't separate, we are all one. We're all together. At the very nethermost element of our being, we are connected. And so we're trying to understand and absorb what are the implications of that. What does this really mean to me in my life?
We need a new spiritual milieu. We need a new spiritual way of understanding the nature of what it is to be a human being. Because the old ways, the old mythologies, the old monarchy, king, God, versus the old lawful scientist way of doing everything are dead. They need to be buried. We need a new realm, a new vision. And I think quantum physics, if anything, could help us get a step up in the right direction.
I think the key aspect of the new paradigm, at least in medicine, which is my little piece, is that consciousness is real and has an impact.
May very well be that what's going on inside of you, in your brain, in your nervous system, in your nature of observation, how memory works, how mind works. It may very well be that what is happening there is some kind of observer-matter interrelationship, which is indeed making things real for you, affecting how you perceive reality. It's not changing the reality out there. You know, you're not changing big chairs and big trucks and bulldozers and rockets taking off. You're not changing those, no. But you're changing how you perceive things and maybe how you think about the things, how you feel about things, how you sense the world.
We know nothing about reality, and all of our sense of so-called reality out there is filtered through our sense organs.
The brain is processing 400 billion bits of information, and our awareness is only on 2,000. That means reality is happening in the brain all the time. It's receiving that information, and yet we haven't integrated it.
People ask me, why does quantum mechanics matter, given that it's little tiny stuff and who cares? There are three possible answers. From a practical point of view, it doesn't make any difference at all. I mean, you still have to go to work and drive your car and do all the rest of it. From a second point of view, it actually infiltrates everything in the world, especially the world of electronics. When you go to the supermarket and you do the scanning at the checkout, that's a quantum mechanical effect. But I think the important part is the third one, which is essentially a philosophical issue. Why are philosophers so passionate about deconstruction the assumptions of the world? I finally got it. I got it as a result of looking at quantum mechanics and comparing it to classical mechanics. They present two very different ways of thinking about the way that the world works and about what we are. So from a classical perspective, we are machines. And in machines, there's no room for a conscious experience. It doesn't matter if a machine dies, you can kill a machine, you can throw it in a dump, it doesn't matter. If that is the way that the world is, then people will behave in that way. But there's another way of thinking about the world which is suggested, it's pointed to by quantum mechanics, which suggested that the world is not this clockwork thing, but it's more like an organism. It's a highly interconnected organismic thing of some type, which extends through space and time. In that kind of environment, what I think and the way that I behave has a much greater impact, not only on myself, but on the rest of the world, than it would if it was a classical world. So from a very basic point of view having to do with morals and ethics, what I think affects the world. That's, I mean, in a sense, that's really the key for why a worldview change is important.
Let's talk about the subatomic world, and then we'll talk about what it's telling us about reality. The first thing I want to tell you about the subatomic world is it's totally a fantasy created by mad physicists trying to figure out what the heck is going on when they do these little experiments. By little experiments, I mean big energy in little spaces and little pieces of time. It gets pretty nutty at that realm of things. And so subatomic physics was invented to try to figure that all out. We need a new science down there. It's called quantum physics, and it is subject to a whole range of debatable hypotheses, thoughts, feelings, intuitions as to what the heck is really going on.
So on the one hand, you had a theory which from the conceptual standpoint was profoundly puzzling, and on the other hand, from the practical standpoint, was vastly more successful than anything we had ever seen before. This is the kind of situation that produces the tension that all of the investigations of foundations of quantum mechanics are feeding off of since then. Because on the one hand, this is an acutely paradoxical, puzzling, conceptually confusing theory. On the other hand, we have no option along the lines of throwing it out or neglecting it, because it is the most powerful, proven tool for predicting the behaviors of physical systems that we have ever had in our hands.
The universe is very strange. There seem to be two sets of laws that govern the universe. In our everyday classical world, meaning at roughly our size and time scales, things are described by Newton's laws of motion, set down hundreds and hundreds of years ago. And they work very well for billiard balls and cannonballs and gravity. However, when we get down to a small scale, when we get down to, say, the level of atoms, a different set of laws take over. These are the quantum laws, quantum theory, quantum mechanics. And at that level, particles may be in multiple places at the same time. They may behave as waves smeared out spatially and temporally. They may be interconnected over great distances. They may be unified into one quantum state, into one state, governed by one wave function. And the borderline, the threshold, this curtain between the quantum world and the classical world is really mysterious. It's called sometimes the collapse of the wave function, because in the quantum world, everything is in superposition of multiple possibilities, and in the classical world, these multiple possibilities seem to collapse to particular definite choices. So everything is in one particular place.
Quantum mechanics is really the play and display of information, the play and display of potentiality, waves of information, waves of potential electron. And it's important, the word potential. This isn't the world of electrons, it's the world of potential electrons. But when you have to ask the question, waves of what, really? What is the field that is waving? Is it the ocean? No, it's a universal ocean, an ocean of pure potentiality, an ocean of abstract potential existence. We call it the unified field, or superstring field. And that's what we're made of.
Connectivity among all things is a basic constituent of the fabric of reality. It's very difficult to wrap your mind around that. But Erwin Schrödinger said, he's one of the founders of quantum mechanics, that entanglement, which is this idea of this connectivity, is not just a property of quantum mechanics, it's the property. It's the property of quantum mechanics that makes it very, very strange. And it doesn't seem to fit in with our ordinary world, our ordinary experience, but in fact, it actually does.
We were all taught in school that the world is made of stuff, of matter, of mass, of atoms. Atoms make up molecules, molecules make up materials, and everything is made of that. But atoms actually are mostly empty. For example, if this ball were the nucleus of an atom, a proton in a hydrogen atom, for example, then the electron circling this, which would describe the outer limits of that atom, would be out by that mountain over there, roughly 20 miles away. And everything in between is empty. In fact, the universe is mostly empty. However, when we go down in scale In the emptiness, we eventually come to a level, the fundamental level of space-time geometry, the fine basement level of the universe, where there's information, there's a pattern. It's called the Planck scale, and it's the fabric of the universe. And at that level, there's information that's been there since the Big Bang. So most of the universe, even of matter, is actually empty.
Most people think that the vacuum is empty. But for internal consistency of quantum mechanics and relativity theory, there is required to be the equivalent of 10 to the 94 grams of mass energy, each gram being E equals mc squared kind of energy. Now that's a huge number, but what does it mean practically? Practically, if I can assume that the universe is flat, and more astronomical data is showing it's pretty darn flat. If I can assume that, then if I take the volume or take the vacuum within a single hydrogen atom, that's about 10 to the minus 23 cubic centimeters. If I take that amount of vacuum and I take the latent energy in that, there is 1 trillion times more energy there than in all of the mass of all of the stars and all of the planets out to 20 billion light years. That's big. That's big. And if consciousness allows you to control even a small fraction of that, creating a Big Bang is no problem.
Another strange fact is that objects never really touch each other. When I dribble this ball, the atoms of the ball and the atoms of the ground never actually meet. It's only in conscious experience that it seems that we move forward in time. In quantum theory, you can also go backwards in time, and there's some suggestion that processes in the brain related to consciousness project backwards in time. For example, in the late 1970s, a neurophysiologist at University of California, San Francisco, named Ben Libet did some very famous experiments. What Libet did was study patients who were having neurosurgery on their brains, with their brains exposed, while they were awake. They were given a local anesthetic to numb the area of the skull and scalp to access their brains. And they were awake, and Ben would talk to these people. So, for example, what he did was he would stimulate their little finger and look at the part of the sensory cortex on the opposite side that was related to that, record from it electrically, and ask the patient when he or she felt the stimulus on the little finger. And he would also stimulate at that particular area of cortex. Now, what you would think would be that if you stimulate the little finger, it takes a finite period of time to get to the opposite side of the cortex, so the patient would report it a fraction of a second later after the stimulus. And when you stimulate it directly, the patient would report it immediately. He found just the opposite. When he stimulated the little finger, the patient felt it immediately, and when he stimulated directly in the cortex, there was a delay. After sorting through all the data and repeating this over and over, Libet came to the conclusion that somehow the brain was projecting information backwards in time, so that it did take a finite amount of time to get to the sensory cortex, but the brain projected it backwards in time so that the conscious perception was that the stimulus was felt when the pinch actually occurred.
And here we are, the granddaddy of all quantum weirdness, the infamous double slit experiment. To understand this experiment, we first need to see how particles, or little balls of matter, act. If we randomly shoot a small object, say a marble, at the screen, we see a pattern on the back wall where they went through the slit and hit. Now, if we add a second slit, we would expect to see a second band duplicated to the right. Now, let's look at waves. The waves hit the slit and radiate out, striking the back wall with the most intensity directly in line with the slit. The line of brightness on the back screen shows that intensity. This is similar to the line the marbles make. But when we add the second slit, something different happens. If the top of one wave meets the bottom of another wave, they cancel each other out. So now There is an interference pattern on the back wall.